And that's by definition. You look back in your notes, guys, at the inverse cosine, those are the only numbers I can use for the x. Now, since Michael brought this up, which as a student, I probably would have said the same thing, guys. This is what is allowed to come out. But Aaron says to put a number inside here. For example, you can't put 2. It's going to be an interpretation for inverse cosine 2. What's inverse cosine 2 mean first? Which really is impossible. It says there's an angle out there whose cosine is 2. And there is no angle out there whose cosine is 2. Cosine goes up to a max of what? 1. And that's what this is right here. So you're caught between -1 and 1 for the domain for inverse cosine. So guys, there's a few examples of domain. There's part 2 done. Let's see if we can get more done here. Part 3, find the complex zeros. Someone remind me, is this the one in part 3? Is this the one I had on the review that you had? You guys had? Yes or no?
Yes.
Same problem? So maybe someone can help me out if it is. Maybe you've already tried this. I'll get this copied down correctly. Okay, this is where you have to use P over Q. You could go through and use Descartes' rule of signs, find the number of possible positive zeros, negative zeros, make sure all that's copied down correctly. I'm going to jump right into it. Guys, we'll just jump right into it and try to find the zeros. First, P over Q, possibilities. All the factors of 10, plus minus 1, plus minus 10. Bart, can he get a copy of this?
No.
Guys, plus minus 1, plus minus 10, plus minus 2, plus minus 5, and the Q should be a factor of my leading coefficient, understood to be a 1. You got that? So not too many numbers that are test. Now, did someone get a chance to try this one?
Mm-hmm.
Okay, tell me what worked.
-2.
-2. So Michael said, Professor, synthetic substitution, try -2. So guys, let me set this up by synthetic. It's going to look like this. He's telling me I'm supposed to get a 0 on the end. Make sure all that's copied down correctly here. Okay, here goes. 0, 1, -2, -7, 14. Help me out here, guys. 9. Then -18. I guess. What's that, 5? Michael, did that work out? I did it real quickly.
Yeah.
Okay, you guys agree? Now, I would love to say, now you could slow down if you could, and rewrite this with the remaining numbers. It means this, which sometimes you can work with at this point. But at this point, it means that sometimes you can take that over to the side there and factor and do something with it and find the remaining zeros. Guys, this one you can't. I thought maybe you could group and do it. You can't do it. So that means no, be on the watch on your test. You might be able to do it on the test. This one I need to test another number. Mike, we have one in mind?
5.
5? Okay, let's try 5. You guys, if I try 5 here, try 0, 1, 5, -2, -10, -1, -5, 0. So far, so good. Now, at this point, maybe I can do what I wanted to do earlier. At this point, those remaining numbers names this. I have x squared, subtract 2x, subtract 1 is equal to 0. Now that I can deal with to find the other zeros. I can't factor. I can use quadratic formula. You guys will do it real quickly. Quadratic formula with some sign changes taking place here. will give me this, 2 plus or minus, looks like we have 4, subtract 4 times 1 times negative 1, all over 2. And looks like it's 2 plus minus, it's gonna be interesting, looks like it's square root 8, all over 2. That 8, I can simplify it, so it's 2 plus minus 2 radical 2, all over 2. Is that true? Reduce it down by 2. Please tell me, is it 1 plus minus radical 2? So do we have all the zeros now? Okay, so my zeros are listed as, let's hope we didn't make a mistake up here, negative 2, 5, 1 plus radical 2, and 1 minus radical 2. Those are my zeros. No i's in this one. Now, did the handout also ask you to put this in factored form?
Yes.
Okay, we write P of x. Here goes. P of x with the numbers, the zeros staring at me. I know this has to be x plus 2. It's going to be next subtract 5. And be very careful on the next 2. The 1 plus radical 2, guys, the factor to get that would be written as this. To get the 1 minus radical 2, who has an idea what the 1 minus radical 2 would have to be written as to get 1 minus radical 2 to come out?
X minus 1 plus radical 2.
There you go. You guys agree? And we're finished. Yeah.
So when you find 1, 0, you can test the other numbers from the results.
You got it,
of
you
that?
got it. Now
You'll
that
have
did
to
that.
go back to.
No, absolutely. So if you want to say, Professor, we tried to do something with this right here, and it wouldn't factor for me. But could I stick with it in my testing, right? And it should. You need not go back to the original.
And how are you supposed to know when one of the numbers is like a multiplicity?
Oh, I gotta let you know, because you'd be wasting time on the test. So if there's a multiple answer, good question. I'd have in my directions, there is 1 0 of multiplicity 2.
Okay.
Just to alert you, there's one's going to work twice. Okay, if I don't alert you, you're going to sit there all day and try to find it, or maybe overlook it. Guys, okay here? Okay. Now, I don't think on the handout, I did not ask you guys to, I don't think I did. I don't think I asked you guys to sketch this, did I? No? Okay, now you know what that would be, like a cross-touch business in behavior, right? So if you had to touch it or graph it with all that in mind. I didn't ask you to sketch this one though. On the exam, I could actually sketch it as a polynomial function, in behavior, cross-touch, and so forth. That was nice then. Now part 4, and I'm gonna have my guest to talk to you. Part 4, guys. Now, Park, if I put part 4 over here, can my students see it?
Yeah.
Can they see all this?
Yes.
Okay, part 4, guys. And on this one, it says solve these equations, and we'll take a little break here. I've got e to the x, subtract 12 e to the negative x, subtract 1 is equal to 0. Someone remind me, what on earth did we do? Melanie, you're the one who gave me a beautiful response the other day. So, you want me to change this right here into what, 12 over? Okay, you don't do, good. We're not gonna move the 12. So how should that middle term look? You're thinking correctly, what is it? It's going to be 12 over e to the x. The only part that you want to move is this right here. With that negative exponent. Okay, the 12 does not have the negative exponent associated with it. So let's write this as e to the x, subtract 12 over, I am going to move this, e to the x minus 1 is equal to 0. That's one way to approach it. Now, it's going to tell me now from there what we're going to do. Is it time to let something be u, or do you want to do something else with it? Melanie? Let u be e to the x, right? So you want me to do this at this point. To make it look like this, guys, it's going to be u, subtract 12 over u, minus 1 is equal to 0. Makes it look a little bit better here to deal with. Now what? It is one of many approaches we could be taking here. What might you suggest now? Yes?
Can we like multiply with u sometimes?
Multiply everything by u?
Yes.
There we go. Now watch what happens, guys, if I multiply everything by u. We'll get a u squared. By 12 over u, the u's would cancel. It leaves me merely at 12. The 1 minus u times 1 is u is equal to 0. Let's multiply everything by u. That's going to be a nice little quadratic. It's out of order, so let's rearrange it. Same quadratic, placed in that order. And guys, as factors, if everything looks good right now, so for u subtract 4, u plus 3. And if I split these up, looks like I'm going to look at u is equal to 4, and u is equal to a negative 3. Is that true? And u with e to the x, so this says you're not quite finished. This is e to the x is equal to 4 by substitution. This one says e to the x is equal to a negative 3. Now, guys, got to be very, very clever. E to the x is equal to 4 implies x must be what? What's x directly? No algebra involved. You should know if e to the x equals 4, x must be ln 4, natural log. These two statements are saying the same thing. These two statements are saying the same thing. If you try it over here, you would have it to look like this. And that's an issue. I cannot have a negative in the domain for a log, a natural log. So that's out, guys. Can't use a negative. So my answer is, after all that work, mine goes way back up here, is ln 4. Okay. I think we have, what, 2 more there? Look at, yeah. Number 3. Wow, wow, wow. Now, are you in a rush? Okay, okay. Because I can stop definitely, because I want you to speak to the class. Number 3 is cosine double theta. Subtract cosine theta is equal to 0. And I want you to solve this on the interval. Looks like it's bracket 0 up to 2 pi. Or did I leave out the log? Okay, I'll come back and pick up the log. I think it's just the third one, right? Okay, I'll come back and pick up the log problem. Let's do the trig first. Who has an idea? Right here, should give you a hint. Cosine double theta. That implies you may want to use a double angle formula. And that's the one that has 3 versions. So you guys say, well, which of those 3 versions, Professor, should I use? Oh, guys, I think the first version was what? Cosine squared minus sine squared. Is that true? Yes. This one, though, with the cosine right here in my second term, I think there's another version that has just cosine in it for the cosine double theta. Does anyone recall what cosine double theta, the version just with cosine?
2 cosine squared theta.
2 cosine squared theta. Minus 1?
Mm-hmm.
You guys agree? And then, of course, this leaves this. Equals 0. Guys, we have things in terms of cosine. It's going to be a nice little quadratic. Let's rearrange it. And it's going to look like this. Rearranged. If you wish, this is another one of these where you could let u be something, in this case cosine theta, and rewrite it, and make it look more like an algebra problem. 2u squared, subtract u, minus 1 is equal to 0. I hope it factors. Oh, you guys, does this bring back some fond memories? It should. 2u, minus 1 plus 1, I think. Split this up. Do not make a mistake here. I'm doing it so quickly. U is equal to a negative 1/2. U is equal to 1. And that says cosine theta is equal to a negative 1/2. Cosine theta is equal to 1. Now, can anyone tell me in this restricted interval, what are the answers? Where have you seen in the unit circle the x-coordinate cosine equal to a negative 1/2? First, where is cosine negative to begin with? The x-coordinate. Which quadrants?
2, 3.
Okay, or 2 and 3. Can anyone name the particular angle in quadrant 2 that has for an x-coordinate negative 1/2? I'm hearing nothing. 2 pi over 3? And you guys said also quadrant, what was it, 3 also? How about the one down in quadrant 3? 4 pi over 3. That takes care of that one. Now, where have you seen cosine equal to a 1? 0. At the very beginning of the unit circle. Now, I said from 0 to 2 pi.
Would you also include 2 pi?
Beautiful. Now, I think I had 2 pi open.
Oh.
2 pi would work, but it's open not to include it. Make sense? And there's a trig equation. Guys, this should really, really benefit you guys for the exam there. Let me pick up number 2 here, then I'm going to slow down here. I think I bypassed number 2. That's a log problem. Log base 2. And we got x plus 2 plus log base 2, 2x subtract 3 is equal to 2. Let's stop down correctly. Does anyone see anything going on here? And
The log base 2 cancel each other out.
now we say cancel out. What do you mean?
Not cancel each other out, but you can just do x plus 2 plus 2x minus 3.
Oh, I knew you were going to say that. I knew you were going to say that's why I placed one like this on the handout. This does alert you to something. Product. It says change this to a product. So that says please rewrite this as one single log, in this case log base 2, and have for a product property, x plus 2 times, not add, 2x subtract 3, and all that's equal to 2. That's step 1 of the property of logs for help, product property. Guys, now what? What are you going to do now? I see a couple of options. You could go ahead and expand this out.
Yeah.
Or you could directly tell me what this entire statement means.
2 squared equals x plus 2
Wow.
times 2x minus 3.
2 squared is equal to x plus 2 times 2x minus 3, and therefore the log's gone. You translate what that means. And here we are right back to a middle school problem. This is 4 Let me go ahead and expand this out, guys. This is two x squared. I think it's gonna be plus x, subtract 6. If I'm looking at it correctly. Let's subtract 4 and rewrite it in good form, if I have no mistake, as that. 2x squared plus x minus 10. You guys agree? I think it factors. Put it over here. Looks like it might. 2x, x, and looks like a 5 and a 2 here, so I gotta get this to work out here. Plus 5 minus 2. Step back and look at it. I think that's it. Split this up. X is equal to a negative 5 halves. X is equal to 2. So, guys, when I select my solution here, that negative number sometimes alarms me. If I should take negative 1/2 real quickly up to the original and replace it right here. That's a negative 2.5 plus 2 gives me what, a negative 1/2? What's wrong with a negative 1/2 coming out here for a log? Should that domain inside here be positive? Okay, so that means not just because it's negative. It won't fall outside the domain, it's out. 2 should work. And let me do it real quickly with you guys. Put a 2 in here, that's 4. The log of 4 of base 2, that's just merely a 2. Put 2 in down here, that becomes 1. 4 subtract 3. Log base 2 of 1, of course, is 0. So yes, I'm going to end up with a 2 here plus 0 here, and I get a 2. That should check. How's that look? Pretty good? Now, let me have my guess. Come on. Oh, my goodness. Introduce himself and let him talk to you about something that just happened and share with you guys, and then we'll get back to this review. Go for it.
What, just share my experience?
Yeah, tell me